Good afternoon, class.
Good afternoon, Mrs. Mui.
Thank you. You can sit down. All right then. We've looked at, we started travel graphs in a previous lesson. We looked at distance time graphs. We will now be looking at velocity time graphs today. But before we do that, you were given questions 3, 4, 5, and 6 to do for homework. And certain students are going to come and give us the answers to the questions. So shall we start with question 3, please? Come and do question 3 on the board. Who is supposed to answer question 3? Peter? As soon as he's finished, if you're doing question 4, come and put up the poster. Okay, question. Just press it.
Question 3 reads, how far from home did the cyclist travel? The cyclist traveled 80 kilometers and then he returned back home. At what time did he begin his journey home? He began his journey home at 1 p.m. and his average speed was 160 kilometers, 82 and 80 back, and 7.5 hours. 160 divided by 7.5 hours equals 21 and 1/3 kilometer per hour.
Thank you. Okay, just going back, the graph shows a cyclist training run. He left home at 8:30 and went as far as 80 kilometers and then back at 4 p.m. It's a whole day's training. Okay. He travels and then rests for 1 hour, travels again, and then returns back at 4 o'clock. He arrives back where he started. Okay, so that's just a graph that represents the information given, and Peter has already given the answers to the questions that follow. All right then, question 4. Okay, make sure you read the question and then explain on the graph the different parts that you draw of the information that's given. Okay, put yours on the right.
Question 4 reads, a motorist starts from X at 11, which is here, intending to launch at Y 100 kilometers away at 13, which is 1 p.m. here. After half an hour, he has a puncture which delays him for 18 minutes from here to here. Yeah. So the question A reads, the first question reads, how fast must he then travel in order to arrive at Y at the right time? Okay. This is the intended distance he was supposed to travel. Okay, from here to here, he's left with 75 kilometers to travel. So 75, which is the rise, over 1 hour, 12 minutes left for him to travel the distance, which is, when I converted it to fraction, which is 1 and 1/5. So 75 over 1 and 1/5, we came with the speed as 62.5 kilometers per hour. The second question reads, at what time will he meet a cyclist who leaves Y at 11:45 and rides towards X at a steady 20 kilometers per hour. Okay, according to the graph, we can see that he meets the cyclist at around 12:45 p.m.
Thank you, Garonamo. Next one, question 5.
Question 5 reads, 3 cars A, B, and C in that order starts one after the other at 5 minutes intervals, traveling at 90 kilometers per hour, 120 kilometers per hour, that's B, and C, 150 kilometers per hour. The question reads, how long after the start of the race does 1. B passes A? As we can see, B passes A at 20 minutes. 2. C passes A. C passes A 20 minutes. C passes A after 25 minutes, and 3, C passes B. C passes B at 30 minutes after the race. Thank you.
Good. The answers again, B passes A after 20 minutes after the race, 30 minutes after the race. C passes A 25 minutes after the race, and C passes B 30 minutes after the race. All right, the last question, question 6.
The question reads, a group of KNHS students start out on a walkathon from Kerava to Rabaul at 5 kilometers per hour with a rest of 10 minutes after each hour's walking. So the graph here shows the rate at which they travel and the resting points. Half an hour later, Mr. Wong's car starts from Kerevat going in the same direction at an average speed of 40 kilometers an hour. So after half an hour, Mr. Wong's car starts here. The car, which does not slow down for the student, stays for half an hour at St. Paul's Vona Canal, 24 kilometers away, and then comes back at the same average speed. How long an interval is there between the two meetings of the car and the walkathoners? We assume that the walkathoners and Mr. Wong meet in this point here after 6 minutes when Mr. Wong leaves Kerevat. And looking at the graph, after probably 90 minutes, they meet again at this point. So 120 minutes is this whole distance they travel. 120 minutes is the whole time it took for him to travel to. No. I mean, 120 minutes is the time here. Minus 36. 36 because of this half an hour here plus the 6 minutes it took. So we came up with 84 minutes, and convert that to hour and minutes is 1 hour 24 minutes.
Did you all agree with the answers? What? Any questions? Okay, number 6. On the horizontal axis, the time is written in minutes, from 20 minutes to 300 minutes, which is how many hours? Okay, but she's also got the 60 minutes here. She's got 1 hour, and then 120 minutes. She's got 2 hours, then 3 hours, 4 hours, and 5 hours. She's also got the number of hours written down. The question is, how long an interval is there between the 2 meetings of the car and the walkathoners? How long an interval is there between 2 meetings of the car and the walkathoners? They first meet here, which is just before 40 minutes, which is around 36 minutes. Okay, that's what she's got here. And here is around 120 minutes. Okay, so 120 minutes minus 36 minutes is 84 minutes, which is around 1 hour 24 minutes. It's approximate because of they didn't use grid. Okay, so I think it's a fair approximate. It's around, they could be 1 hour 25, 1 hour 30, but that's okay, that's good enough. Okay, for today's lesson, we are going to look at velocity time graphs. There is a chapter in your book that discusses travel graphs, and it discusses distance time graphs and velocity time graphs as well. So if you go back and check your textbook, you will see this. Okay, the definition for velocity is the speed in a given direction. Okay, it's usually measured in meters per second or kilometers per hour, whatever units are used. Right, again, it's the speed in a given direction. Okay, if a velocity time graph is drawn, the area under the graph gives the distance traveled. The gradient of the curve gives the acceleration. I'm going to explain later when you look at the actual graph. It is slightly different from the distance time graph. For the distance time graph, when you have a line that is sloping, the gradient of that line is going to give you the speed. This one, it's different. The gradient of the line will actually give you the acceleration. Okay, so what is acceleration? Right, it's the rate of change of velocity, and it's with respect to time. Okay, so as velocity, it's actually you can also look at it as the speed with respect to time, or the change in speed with respect to time. So acceleration is the rate of change of velocity. It is measured in meters per second squared, meters per second, or it can be measured in kilometers per hour squared or per hour. Right, that's why you've got the units that way. Okay, I'm going to just give you an example of a graph. Maybe I'll just draw one quickly on the board. Okay, if this is velocity, also you will see speed, and it's meters per second, and time on the horizontal axis. If a graph was drawn like this, again this is time, and let's say it's in seconds, and velocity is in meters per second, or sometimes you'll be given speed in meters per second. Like I said, the gradient of this line will not give speed, it will give the acceleration, because the rise is meters per second and the run is seconds. So it's going to be meters per second over second again. That's why you end up with meters per second squared. Okay, so it's the gradient of this line is going to give acceleration. Okay, a horizontal line will mean what? No, that's where you are wrong. It will give constant speed or constant velocity. Okay, constant velocity. If it's a distance time graph, then it means resting time, no traveling. Okay, this one would be the same as that. That's acceleration, and then that's constant velocity. That means there is no acceleration. Okay, and a line like this will mean either deceleration or sometimes it can be called retardation. Okay, it means that the traveler is just slowing down. Okay, now if a question is asked, what is the deceleration? Now deceleration already means negative acceleration, so you don't put the negative sign in front of the number. Retardation already indicates negative acceleration. If you are asked for the acceleration here, then you will put the negative sign in front of the number that you're putting down. All right, with deceleration and retardation, it's positive because they already indicate negative acceleration. Okay, I've just got a few more notes there. If the acceleration is constant, then the velocity time graph will be a straight line. Like in this case, the acceleration from here to here will be constant. It will be the same. Then it's a straight line. If acceleration is not constant, then it means you're actually going to have a curve, which we will not look at this year. You will look at that next year. Okay. When the velocity is increasing, the graph has a positive gradient. If the velocity is decreasing, there is deceleration, which is this, and sometimes called retardation, and the graph has a negative gradient. Okay, negative acceleration means the velocity is decreasing or it's slowing down. The traveler is slowing down. Okay, if you wanted to find the distance traveled between in this journey, let's say represented by this graph, the distance traveled, the area under the graph means, because in the beginning, if I can just go back. Okay, it says where did I put it down? The area under the curve, under the graph, gives the distance traveled. Okay, so if you are asked what is the total distance, let's say if this was 0 and this was maybe 20 seconds. And if you are asked what is the total distance that is traveled by this particular traveler, what you will do is you will have to draw sections of this graph, and you will actually have to find the area under the curve, which consists of different shapes. There's a triangle, a rectangle, a triangle, and a trapezium. So all of the area under the curve here, it's called the area under the curve, that will represent the distance that is traveled by the person that's traveling. Okay, and the exercise, the first exercise is asking you to state the distance that is traveled. So I'm going to just do the first one for you. We'll do that together. Okay, the time given is in seconds and the speed is in meters per second. All right, all you have to do is find the area under the curve. So the time travel is 6 seconds, and the speed that is traveled within that time is 10 meters per second. So all you have to do is multiply 6 by 10, you get 60 meters. And note also, it agrees with the formula that speed is equal to distance over time, and distance is equal to speed times the time. That's why you have to actually find the area under the curve. Make sense? Okay. I'll just give you 5 minutes to do B and maybe C. Finished, B? Finished, B? One more. Oh, okay. All right, for letter B, half of 12 is 6, so you should have 6 meters. This one, 20 times 2 is 40, 40 plus 40, 80 meters. Yes? 240 divided by 2, 120 meters. And E, 300 meters. You can either divide that into a rectangle and a triangle, but it's also a trapezium. You can look at it. These are the two parallel sides, this one and this one. And this would be the perpendicular height. Okay, you are going to do number 2. And number 3 and number 4. Number 5. Number 6. You are all smart, so you are going to complete it. Okay, the keyword to the pilot teacher is velocity. Good afternoon, class. Thank you.
love you